Hi, welcome to UNIX Academy. We are learning Kubernetes interview and as well as certification level question and answers. Let's come to the video. How can you access the storage in pods? This is a question. A pod can specify a set of shared storage volumes. All containers in the pod can access the shared volumes, allowing those containers to share data. Volumes can also allow persistent data in a pod to survive in case one of the containers within needs to be restarted. Tell me the pod networking. Pod networking is very important. Each pod is assigned a unique IP address for each address family. Every container in a pod shares the network namespace, including the IP address and network ports. Inside a pod, the containers that belong to the pod can communicate with one another using localhost. When containers in a pod communicate with the entities outside the pod, then they must coordinate how they use the shared network resources such as ports. Within a pod, containers share an IP address and port space and can find each other via localhost. The containers in a pod can also communicate with each other using standard inter-process communication like system semaphores or POSIX shared memory. Containers in different pods have distinct IP addresses and cannot communicate by OS level IPC without a special configuration. Containers that want to interact with a container running in a different pod can use IP networking to communicate. What is the mean by static pods? Static pods are managed directly by the kubelet daemon on a specific node without the API server observing them, whereas most pods are managed by the control plane, for example, a deployment. A static pods, the kubelet directly supervises each static pod and restarts if it is fails. Static pods are always bound to one kubelet on a specific node. The main use for static pods is to run a self-hosted control plane. In other words, using the kubelet to supervise the individual control plane components. The kubelet automatically tries to create a mirror pod on the Kubernetes API server for each static pod. This means that the pods running on a node are visible on the API server but cannot be controlled from here. Note here, the spec of a static pod cannot refer to other API objects like service account, config map, secret, etc. Explain the pod life cycle. Pods follow a defined life cycle, starting in the pending phase, moving through running if at least one of its primary containers starts okay, and then through each the succeeded or failed phases depending on whether any container in the pod terminated in failure. While a pod is running, the kubelet is able to restart containers to handle some kind of faults. Within a pod, Kubernetes tracks different container states and determines what action to take to make the pod healthy again. Pods are only scheduled once in their lifetime. Once a pod is scheduled, means assigned to a node, the pod runs on that node until it stops or it terminated. Then explain the pod life cycle. Pod lifetime. Pod life cycle is different. Pod lifetime also different. Like individual application containers, pods are considered to be relatively ephemeral rather than durable entities. Pods are created, assigned a unique ID, and scheduled to nodes where they remain until termination according to restart policy or deletion. If a node dies, the pods scheduled to that node are scheduled for deletion after a timeout period. Pods do not by themselves self-heal. If a pod is scheduled to a node that then fails, the pod is deleted. Likewise, a pod won't survive an eviction due to a lack of resources or node maintenance. Kubernetes uses a higher level abstraction called a controller that handles the work of managing the relatively disposable pod instances. A given pod as defined by a user ID is never rescheduled to a different node. Instead, that pod can be replaced by a new, near identical pod within even the same name if desired, but with a different user ID, unique ID. When something is said to have the same life cycle as a pod, such as a volume, that means that the things exists as long as that specific pod exists. If that pod is deleted for any reason, and even if an identical replacement is created, the related thing, a volume in this example, is also destroyed and created a new. That's about this video. Thanks for watching.